The file of CSG, give him a round of applause. Thanks, Karen Robert. I think if everybody could, everybody in the swim lane, just like take a seat. Yeah, cool. And we can begin. Go for it.
Thanks, Matthew. Right, cool. So yeah, I'm Rob. Outside of CSG, this is actually one of the first times I've spoken at a meetup, so I'm kind of new with this as well, besides the lightning talk guys. So feedback, welcome. Tonight I want to challenge you about the way you think, the way you get to solutions, and the value that you add to your projects and your teams. Okay, so all of that in about 10 minutes. Thinking interests me. How I think interests me, how you think and my teams think interests me, and the fact that you can change your thinking also interests me. So I don't really care what you do. You can be a manager, a tester, a technical writer, a scrum master. You could have worked at a startup, you could have worked at a corporate. I've done pretty much all of those. The only two things on that list that I haven't done officially is a tester and a technical writer. But I think I'm going to tell you a story about my journey, because along my journey I've basically been kicked in the head 3 times. So I want to kick you in the head. And those kicks in the head basically changed and shaped the way that I've started to think, or have thought over the past little while. A lot of what I'm going to tell you is not new. It's information's out there. It's just me stringing it together for you. All right. So hopefully you can get something out of it. Some influences, but I'm not going to go into that too much. But Alistair Cockburn, we all know Alistair Cockburn, yeah? Okay. So he describes software development as a collaborative game, or a series of collaborative games, which is kind of cool. So kind of what I hope to get out of this evening is for you to go away and play the game a little bit better and help your team play that game a little bit better. So let's start with the why. Okay, so let's start with why. Who said that? Anybody know? Simon Sinek, exactly right. Okay, so tonight I want to challenge your discipline. So how much time do you spend in the problem space versus the solution space? I want to kind of challenge you as to how you strain your brain, and I want to plant a splinter in your mind. I want you to remember return 42. Okay. So our world is mostly about problem solving. We're thought workers, we solve problems for a living. We do this all day, we do this every day. In our collaborative game, however, we know most about the problem that we're going to solve and the way in which we solve it at the end. True story, right? So I want to kind of harness that and try and bring the pain forward a little bit. So the 3 things that I'm going to touch on this evening are: how do we understand the problem that we're trying to solve? How can we then rethink that problem that we're trying to solve, boiling it down to truths, boiling it down to elemental parts, and then constructing solutions that are possibly illogical, but add value quickly. All right, so the first thing that I want to talk about, this is not in chronological order in the order that I got kicked in the head with them, but the first thing I want to talk about is 2 spaces, the problem space and the solution space. So these 2 spaces exist. And what I've observed is that folk generally like to jump into the solution space relatively quickly. So you might have experienced this with your teams, or when you're working on issues. You might spend time focusing on the solution really early on. So it might be in the context of your team, they're 10 steps down the solution path, but they haven't yet actually understood what the problem is about. There's that uneasy feeling that we're not quite sure what it is we're supposed to be doing. Anybody experience that?
Yes.
All the time, right?
All the time.
Okay, all the time. And how does that play out for you? So typically it might be the stand-up the day after your planning, or sometime into your sprint, and people are like, what the hell are we actually trying to do here? I thought we were trying to do this. No, we were trying to do that. And things go slightly pear-shaped. Okay. So my experience when I got kicked in the head the first time was I attended a course on analytical thinking and creative problem solving many years ago. And these 2 spaces were presented to me. I didn't actually understand them before I'd actually come to this course. And it was pretty interesting because my natural inclination was to jump into the solution space. I want to be the first person to get to the solution. It's not a game, maybe. But I realized that there was a lot of value in exploring the problem space. So understanding really what it is we're trying to solve. And this applies to all disciplines, right? As it turns out, it is foreign, but it is something and a discipline that you can learn. So bringing yourself back into the problem space, you're not trying to design a space pen when a pencil's available. So this is something you can help your teams with in that collaborative game. All right, so there's a lot of information about this. I'm just going to plant some seeds. All right, so problem space versus solution space. There are other interesting side effects that exploring the problem space has. So it allows for more creativity. If you understand more about the problem that you're trying to solve, you can actually be more creative about the solutions that you come up with. And things like set-based design can come into your thinking as well, so you don't diverge too quickly, right? Okay, so I like quotes, so if you can't explain it simply, you don't understand it well. It kind of applies here as well. So if you don't understand the problem that you're trying to solve, you might need to go back to the drawing board. Okay, so that's the first mission, right? All I wanted to do was challenge the way you think about the problem. Okay. The next thing that I want to bring to you is first principles. So thinking in first principles or first principle reasoning. So again, in those team settings, you might be faced with situations where the team is discussing how we can build on X. How we already know this, how do we change that? But do we really know? First principle thinking is about breaking things down into core elements and establishing truths. So it's getting rid of biases, testing assumptions, and making sure that you're dealing in truth. I first ran into this and got kicked in the head when I was studying engineering, and a lot of what you do is based on first principles. So I had prepared for a structural engineering exam. I programmed all the equations that I needed to use into my HP48GX calculator, and I knew how to apply those guys. But there was one question on that paper, and it was from first principles, derive said equation. So I've carried that big fat zero around with me for a long time, but it really did adjust the way that I thought about problems and making sure that you really understood what was truth. Are you building on something that is solid, or are you building on sand, really? So you don't just need to take this from me. Elon Musk has spent a lot of time, and this is he's got a lot of material out there on how SpaceX, how his rocket projects are based on this type of thinking. So boil it down, strain your brain. It does take effort to try and break things down into elemental parts and test your assumptions. But at the end of the day, it allows you to come up with more creative solutions because you are dealing with fundamentals and truths. Okay, so that's the second mission, really. Just plant the seed, be aware of this type of thinking and what it can buy you. Okay, the third thing that I want to talk to you about is doing the thing that adds value quickly. So I've talked about exploring the problem space. I've talked about how you can break your problems down into fundamental parts and truth. Now the third thing is, what do you do with that? So how do you then look at your goals, look at your objectives, and get to value quickly? So one of the lean principles is trying to add value in the shortest sustainable lead time with quality, right? So that's, we all know that. And once you've broken these things down, trying something that might, the thing that actually adds the value might be logical, right? So who ever thought that writing a test before you wrote the code could be a thing? So test-driven development, actually, when you first see it, seems illogical, right? But it's a mainstream thing, and there's many books and videos and all sorts of things that have been produced about this. But initially it seems illogical. So the third thing that I'm going to talk about is where I got kicked in the head for the third time. So this is really what test-driven development looks like. So I'm not going to go into this very deeply. I'm just going to give you a very basic idea. So it's called red-green refactor development. And effectively, you start off with a test. So I want to prove something. You make it fail. It's red. You do the shortest amount of coding to make it go green, so the test passes. And then you refactor it and make the code beautiful. Okay. So get to the value quickly. The reason I tell you this is because the third kick in the head came from a test-driven development example. So I just needed to put that out there so we know what we're talking about. Okay. So you can only see this once. And I saw this with one of Robert D. Martin's cutters, and he was doing some multiplication and arithmetic with numbers. All right, there we go. So you didn't hear the first like 10 minutes. With numbers.
Can you just repeat that?
Yeah. So as you would with test-driven development, you break things down into a small piece. So in this case, he wanted to multiply two numbers together, those numbers being 6 and 7, and he wrote a test for it. So some test code might look like that. Test multiplication insert equals that the product of 6 and 7 is 42. So he wrote that code, fantastic, and then he started to write his implementation. And he wrote the multiply method in his actual code, the production code that's going to go out. And he did something very strange. He wrote return 42. It's not just the answer at the end of the universe, but that's really the money shot, right? And this kicked me in the head. So I thought, that's a cheat. That can't be. How can you just return 42? But if you think about it, so what he's done is he's broken down his problem into something simple. So I'm going to start off with one example where one case where I'm multiplying 6 by 7. I'm then going to, if you think about first principles, I know the truth of 6 times 7 is 42, and the quickest way to add value is just to return 42, and that's essentially what he did. So that kind of thinking can actually be applied in many other places. This is the first time I saw it. And the more you think about it, the more it actually makes a whole lot of sense. Of course, this also fits in with some design principles, right? So you don't abstract, you don't generalize until you have a second case. So of course, this code will change. But it's interesting that you can do the quickest thing to add the value, right? Okay. There's a whole bunch of other stuff on return 42 as well. I was actually trying to find the code snippet, and it's become a real thing actually. So that was the third mission that I wanted to take you on, really, is I want you to hear return 42 in the back of your mind when you're thinking about solutions. What is the quickest thing that I can do that adds the value to the problem that I'm trying to solve? Okay, so I know that covered a lot of ground, those three little missions. So there are some references here on all of them. There's a lot of material out there. But I just want to leave you with two other things. So it's not just enough to do your best. You must know what to do and then do your best. So what is that what to do? You must understand the problem that you're trying to get to. Okay, so takeaways. Spend time in the problem space. First place I got kicked in the head. First principle reasoning can help you identify core elements and build on truths. And the shortest distance between 2 points can be uncomfortable at first. And then I think Steve said this earlier as well. The correct answer is always, well, it depends. Okay, yeah, there's some things to Google. The slide deck has a whole bunch of other things. I just realized I wouldn't fit it into 10 minutes. But there are some other slides in there as well with some of the examples that you might want to look at. Cool. Questions? I'll work with him.
Do you have a question, sir? Any questions?
How many rows the man walked down?
Hi, my name is Anton,
Okay, Anton.
I'm not sure whether I think I got lost somewhere. My brain likes to calculate too much. I saw those two you wrote. I don't know whether that was an example or not, where you had two functions there, one with parameters that you put in, and then the other one you didn't define the variables, and then you return the value. That just confused me there. Which is, what was the point of, in the way you were saying, my thinking is like, what is the point of them testing it if you already, at the end, you've defined the value, which is 42 in this. So it's like testing, let's say you have a component and then you run with it, but then again at the end you already know what the expected result is. So what is the point?
So that is exactly the point. Initially it doesn't make sense, right? So if I'm looking at my TDD example, I get my test to pass because it works. I've actually done the minimum amount of work to complete my cycle. As I add more code, because I'm not only going to, my calculator is not only going to add or multiply 6 and 7, right? It might add or any other number. So I'm eventually going to have to break that down. But the point of this example is that initially do the thing that seems illogical to get to your result. Right? So it applies to many areas. You don't have to build something that you don't necessarily need now. What is the next simplest thing that I need to do? So one of the agile principles is simplicity, the art of maximizing the work not done. I think that kind of illustrates that pretty well, right? Okay, so that's the point. It's not supposed to make sense. And then it does, that art.
Rebuttal? No? You good? Maybe?
Just to add on then.
Okay, question number 2 is coming from the back.
He says that you must do something that is simple now to fix the problem that you have, which is all good and well, but if things change, if you started coding in 96, your VAT would have been 14%, you would have hard-coded it, like all the shit around. Then come this year, then you have to change everything, which is much costly. So it doesn't.
Yeah, so I'm not talking about not externalizing things like what a VAT value should be, right? So that's a coding design implementation. This is looking at how to get, because this is not going to be the end code, right? So there's one of the classes in here as well that Robert C. Martin does is about prime numbers. He ends up with 3 lines of code but 50 lines of text following the same principle. So each test shapes how you think and what you do next. And it's really interesting watching that as well. So it's also kind of a kick in the head because the solutions actually just fall out at the end because you're focusing on just the small next step that I need to take. And you actually kind of almost sidestep the bigger problem and you don't worry about this whole, the expanse of the problem. Part of what test-driven design is designed to do. It's designed to make you think just about this problem, just about the context of this problem, solve for that. And when you take a step back after doing that for a bit, you go, well, I've already coded the solution, how the hell did that happen? But it did. Yeah. So I'm not saying hard code values like that into your code, that's bad.
Okay, one last question. You look very excited.
No, I'm not.
Not excited?
Yeah.
Speaking already. Speaking to the mic.
Yeah, just to add to the question, so I know what you explained there about hard coding 42, so I would think you'll make it a variable so that as you test, then you'll change the value. Is the code missing on that implementation code?
Yeah. So that is the first iteration of implementation code. So this cycle happens again and again and again and again and again until you're done, right? So there's actually, it's a double loop because you've got a higher level test function, your acceptance test, which then drop down into your tests, your TDD stuff. So this cycle, it's kind of like instant gratification, right? So I need to prove something. What is the shortest thing I can do to prove it? Fantastic. What is the next shortest thing that I need to prove? Okay, I can prove it. Refactor my code. Yeah?
Nah.
No. So one of the links in here is actually because I realized that not everybody knows some TDD, but there's some TDD cutters in there, and there's some TDD dojo stuff in there as well. Yeah.
One thing, maybe I can clarify for him as a developer in test. So you're saying basically, if I understand you very well, right? You get the output, right? Output is 42. How you get to 42, there's plenty of ways to get there, right? There's plenty of ways to kill a cat. Not?
No.
Nah.
So the thing you need to take away from this is value quickly. Yeah. That's all you want.
Yeah.
Quickest.
The
So
quickest way
how
you
does
get
your
to
crow
that
fly? The shortest distance between 2 points is return 42, right?
He's also based on building a calculator.
Yeah. Yeah. So this is only part of it, right? Yeah.
Example of
No?
No, we'll chat. No, it's fine. We'll chat here.
I was going to check if there's just, in a second, one last question to roll the evening over. Like, maybe take the conversation somewhere else. Not because I thought it was bad, just because there's a moment, if anybody had a question that wasn't along that line, if they wanted to ask it. Okay, now I'm going to awkwardly stand here until Matt gets back. If a question pops up in somebody else's mind in the interim, feel free to raise your hand. There we go, Sintu. Thank you so much, saving us. By the grace of Sintu.
Yes, by the grace of Sintu. Alright, I get that you can build software like this very quickly. And that example I've heard earlier was a very good one. Are you designing software that will be obsolete in 10 years because technology evolves so fast that there's no point in developing the best calculator ever?
So I hear you, but I think we're talking past each other here. So the three things that I want to leave you with is explore the problem space before moving into the solution space too early, right? Second thing, use fundamentals. Okay, so first principle. Third thing, look at getting to the value quickly, right? So yeah, I'm actually not talking coding at all. I'm talking a concept here. So I'm up a couple of levels. So what is the shortest way so we want to go to space, we want to write in space. We could spend $1 billion developing a space pen, or I could just use a pencil. That's the value, quickly.
Sweet. Thanks, Robert.
Thanks, Rob.
Okay, cool. This is the end. We're like 40 minutes over time. No, it's like 30 minutes over time. Okay. Just like a post thank you to like everybody speaking in the back. No, I'm serious. Like, hey guys, everybody, thanks for coming out. So to the community, like we've already had thanks to the speakers and everybody running the games and the crew, but like really a huge thank you for you, all of you that came out and are here to the community. Our next meetup is on the 7th of August, and you can already RSVP to it on meetup.com. So do that. We're always looking for venues and sponsors, although we've lined them up for the next while. If you have a venue or you have a cool sponsor, let us know. Or if you want to get involved with the committee or the casual crew, which just help out at meetups, then let us know. So anybody in a weird white shirt, yeah, just go up to them and tell them you want to be as equally weird. Rachel said it earlier, like sign up for the lightning talks. And now that I'm talking about Rachel, Rachel wants to have a word about the activities.
Cool guys, so I'm not a tester. So I do the stuff at the beginning. I understand the later stuff because that's what being multifaceted is, but I'm not a tester by practice. So what I'm going to do right now is give some props to all the people who participate.